call that log base A of y equals to x means A to x equals to y. Right? So what's inverse of A to x? So we'll introduce natural log. Natural log of x equals to y means e to y equals to x. So natural log is the inverse of e to x function. So we switch an input and output. So you see here input, see here output. When we switch into exponential function, x, which used to be input, becomes output. Y, which used to be output, becomes input. Okay, so that's what we're doing. We're switching input and outputs. Right? Now let's look at the graphs. E is bigger than 1, so e to the x is exponential growth. So the graph of e to x is going to look like exponential growth. Right? So that's the graph of y equals e to x. Now, if you want to build the graph of log, natural log x, that is inverse function. And you recall the graph of inverse function, what we do is we flip it, we switch x and y's. So we switch x and y's. So we switch in x and y's. So when we switch in x and y, we're flipping it around straight line y equals to x. We're going to flip it around straight line y equals to x. So if we flip it, we're going to get the graph of e to x, natural log, I guess. So I'm going to write it like this. So that's the graph of y equals ln of x. So that is 1, and that is 1, 2. Okay, so that's the graph. Okay, and if we go a little bit more, then we notice that range of e to x is from 0 to infinity. Okay. Using interval notation 0 to plus infinity. Domain of e to x is all numbers from negative infinity to plus infinity. Right? So that's range and domain of e to x. For natural log, we're going to switch range and domain of e to x. Right? So we're going to flip them. So whatever was range, now it's domain. Whatever it was domain, now it's range. So domain of natural log is range of e to x. So it is only when x is positive. 0 to plus infinity. Range of natural log is all numbers. Okay. So that's this command. Okay. Now the property. Just have a look, for example, if we have function y equals ln of x. So what it does is, if I take input x, right, it calculates output. And we're going to get y equals ln of x. So it takes input of x, calculate output ln, and that's what it is. Now, exponential function, each over, is inverse of natural log. So we inverse to each other. So what it does is it takes its output, which is y, and put it back into x, right? Because that's what inverse function does. It switches outputs and inputs. So that's what e to y will do. So it takes now y, which is output of old function of natural log, it takes and it puts it back to e2. Okay. And that's what kind of picture which we have. Okay. So e to y equals to x and y equals to ln of x. So from here we can write down a couple of formulas, for example. So for example, e to, you recall that y is ln of x, e to ln of x equals to x. That's a property. And that's for x which are greater than 0. Because ln of x has to be defined. If we cannot calculate ln of x, that expression makes no sense. So that's a property. Now let's use this property to calculate the derivative of natural log. So, next question, we want to find what will be the derivative of natural log of x. So that's the next question. So I start with name column. I say y equals ln of x. I want to find the derivative, but I don't know how to find the derivative. So what I want to do is I want to get rid of ln of x. And to get rid of ln of x, I will use that formula which we have here on top. So I will take e to power y equals e to power ln of x. As long as I'm doing the same for two sides, I'm in good shape. Now I can rewrite right expression as e to the ln of x as just x. So I'm going to get e to y equals to x. Now I will take derivative. Derivative of x is just 1. Derivative e to y, I have to do implicit differentiation. All right, e to y times y prime, because I'm going to treat y as a function. Same way as we did in our first example when we're taking derivatives e to 5x, e to 7x. So we get that. Now we're going to substitute back what y is. I recall that y equals to ln of x. So I'm going to substitute it here back. So I'm going to get e to the ln of x times derivative of ln of x equals to 1. E to the ln of x equals to x. So we're going to get x times derivative of ln of x equals to 1. So derivative of ln of x equals to 1 over x. That's next formula which you want to remember. I guess Usually the formulas comes in pairs. So for example, derivative of ln of x is 1 over x. If I go the opposite direction, antiderivative of 1 over x is ln of x. And actually here we'll put absolute value because derivative of ln of x equals to 1 over x. It works when x is positive, but antiderivative of 1 over x dx equals to natural log of x also works when x is positive, but when x is negative, you just put absolute value. Okay, so example, find integral dx over 3x. So take 1/3 out. So we're going to get 1/3 natural log of x plus